What is, first of all, we have to know about what is SSAS. SSAS means SQL Server Analysis Services. It is the one of the important module in MSBA, Microsoft Business Intelligence. Here, see, it is used for to develop the OLTP database, OLAP database. What is OLAP? It is nothing but just cube. Okay, these cubes are queried with MDX language, multi-dimensional query language. Okay, now we can use SSAS to create cubes using from data marts and data warehouse. Okay, with the help of data warehouse or the data marts, we can create the cubes. These cubes will give deeper as well as faster analysis. So cubes are multi-dimensional data sources. They have dimensions and facts. First of all, what is dimension? What is fact? Cube consists of only dimensions and facts. First of all, we have to know about what is fact. Fact is nothing but the fact table consists of the actual business facts, like on numbers, values, like that. We can also call it as measures. So it contains some foreign keys. That foreign keys as referred and for primary keys in dimensional tables. But we have to know about what is dimension. The dimension table consists of only attributes. We can also call it as fields. Okay, this is just about what is cube. Cube means it will consist of dimensions as well as facts. So what is fact and what is dimension? It is about cube. So first of all, we have to know about what is the benefit of cube. Why we are creating the cube in MSBA. See, it will increase the speed of the database. So whenever you are having the data in cube format, you will get the data or you will get the reports within the fraction of time. Even though we have 1 million records in the cube, we will just extract the data within a fraction of seconds. It is the main advantage of the cube. So that is the reason why we are mainly using these cubes, and as well as it will provide good security and it will automatically handle the SCDS slowly changing dimensions, and it will support some drill through actions. Okay, it is the main advantage in SSAS. So see, I'm coming to the data warehousing architecture. Here you can see this is called OLTP, online transaction processing. Here the data will be stored in table format. This database is called relational database management system. The data will be stored in normal table format. So once we can extract that with the help of SSIS, we will just load the data into some database. Once we can load the data into database, what we will do, we just create the reports directly with the help of SSRS. But if you create the directly reports with the help of SSRS, what will happen? If you get queries, for example, if your requirements, if you have to provide 1 lakh queries at a time to the data warehouse, what will happen? It will take a lot of time. So instead of that, what we can do, we just implement the cubes with the help of SSAS. Okay, this SQL Server Analysis Services. With the help of SSAS, we just implement the cubes. Okay, this is called multi-dimensional database. Here the data will be stored in cube format. Okay, so compared to table format, the cube format will give lot of, it has a lot of difference. It will give very lot of performance, and whenever you write a query, either 1 lakh or 2 lakh queries at a time, it will retrieve the data fraction of seconds. This is the major difference between the cube format as well as table format. Okay, now see here we can actually use this module SSAS. Okay, in data warehouse where we can use this SSAS. See here we can use SSAS. The help of SSAS, we just extract the data from multiple sources into one destination, and after we just use this SSAS and we just create the cubes, and here you can use SSRS, so you just implement the reports. Okay, now first of all, I just now told you what is cube and what is facts and what is dimensions. So see here mainly we have in this SSAS we have data modeling techniques. Here we have two types of schemas. First of all, we have to know about what is schema. It means a relationship between columns or tables is nothing but schema. So it will give clear picture about the tables, how the tables are related to each other. Okay. See, here we have mainly two types of schema, star schema as well as snowflake schema. See, while coming to the star schema, whenever, for example, whenever one fact table surrounded by, I'm going to show that structure. See, this is our star schema. See, whenever one fact table surrounded by these all these tables all are called dimensional tables. Okay. Whenever one fact table is surrounded by multiple dimensional tables, that is called star schema. Now see, if you want to put one more table, see, here also you can put one more table. The structure look like star. So this is called star schema. The architecture also would like star. Each dimensional table having, see, primary key. This is a primary key. This is a primary key. ID is a primary key. Dim date as well as in dim store also ID is a primary key. In dim product also ID is the primary key. See, each primary key will refer some foreign key in fact sets. Okay, this structure is called star schema. Okay, what about snowflake schema? See, this is snowflake schema. It is an extension of the star schema. See, we have one fact table and 4-dimensional table. Again, this dimensional table refers some dimensional table. This is nothing but snowflake schema. So whenever the dimensional table will connected with some other dimensional table, that is called snowflake schema. Okay. Now coming to the for example, I will give you some example for this. See, it's just example. See, here we have one cube. Here we have 60, 40, 50, 100, 20, 30. These all are called quantity. What is quantity? It will refer some fact table. And now here we have four. See, these 3-dimensional tables. Dimension table dim date. What is this? See, it is our dim date dimensional table. It is our product dimension table and it is our geography dimension table. Okay. Now we can see this is our dimension table for dim time. So here here is the attribute. What are the columns we have in the dimension table that all are called? What are the attributes? Okay. And see, under the attributes, what are the data we have? That is called attribute members. Here my dimension table is dim time. This is my dimension table. Here I take one attribute that is called year. 2001, 2002, 2003, 2004. These all are called years. So I take attribute year. See, under the year I have data related to 2001, 2002, 2003. This is called attribute member. Okay. Same for dimension dim product also. See here. This is our dim product. I take the category is my attribute. Under category, see, I have data that is called attribute members. Same for, see, geography also. Here I take attribute country. See, in country we have US, UK, Canada. These are attribute members. For example, if we take some India, here in India, under the India we have Chennai, Bangalore. These all are called cities. Like that. Okay. These all are called dimension tables, and we have one fact table. Okay. Under the fact table here you can see sales amount is our measure. Under the sales amount, what are the quantity we have? 10,000, 20,000, anything. That is called measure member. Same as here, 1,000, 2,000 like that. This is called measure members. Okay. What are the fields we have in fact cell? That is called measures. What are the fields we have under the dimension? That is called attribute. Okay. Nothing is there. Just try to understand. And now coming to the hierarchy. What is hierarchy? For example, see here I took hierarchy level year. Okay, whenever I expand the hierarchy year, then only I will get the year information 2001, 2010, 2005 like that. See,